Okay, we're going to add, subtract, multiply, divide, and simplify radical expressions. We're starting off with a blue rule in green here. The nth root of a to the n power, okay, equals the absolute value of a if n is even, and it equals a if n is odd. N has to be a positive integer. So what does all that mean? It's just real simple. It's just if you got the square root, for example, of negative 3 squared, that does not equal negative 3. It equals the absolute value of negative 3, which equals 3. Okay? But if you take the cube root of negative 3 to the third power, that equals negative 3. You see, if you've got an odd power here, then if this is positive or negative, doesn't matter. You're going to wind up with a. Whatever a is, that's what's going to be out here. But if you're finding the square root of a square, or if you're finding the fourth root or the sixth root or the eighth root of something taken to the fourth, sixth, or eighth power, then you got to get rid of the negative sign. In other words, you can't have a negative sign when you have an even. When n is even, you can't have a negative sign. You're not going to end up with a negative. And so, what does that all mean? Let's try a couple of things that we're going to use this rule for. Okay, let's try. And I hate those little doodads there. So, all right, let's try. Square root of 49 x squared y to the fifth z to the sixth. Okay, we're going to find the square root of that. Well, I'm going to show you a simple trick here, and that is you find the square root of a bunch of squares. Like 49 is 7 squared. Okay, x squared, of course, is x squared. Y to the fifth. Now look at y to the fifth. That's y squared squared times y. Now, why would I put it that way? You know, this is y to the fourth because 2 times 2. So why would I put it that way? Watch. Y squared squared. And then over here I'm going to put y. Okay? And so I've taken care of this y to the fifth. Z to the sixth. Well, that's z to the third to the second power, right? So we'll say z to the third to the second power. So why would I do all this stuff and mix it all up like that? Here's why. Watch. 7 times the absolute value of x times y squared, and I'll talk about that in a minute, times the absolute value of z to the third, okay, times the square root of y. How did we do all that stuff? Well, let me show you something. 7 squared is 7. I don't have to worry about making that absolute value because this is not a negative, so it's just positive 7. I don't know what x is. X might be negative 4. So I can't say that this equals x. I have to say it's the absolute value of x because of the rule we just talked about. Okay? Y squared. Why didn't I make this the absolute value of y squared? Very simple. When you square a number, you get rid of the negative. So y squared, that's just y squared. Z to the third, I have to make that absolute value because if z is negative 2, then z to the third would be negative, and it can't be negative. It has to be positive. So the absolute value of z to the third, and finally y is all by itself, and so I have to put that, I have to leave that under the radical sign. Okay? So, what's all that about? Well, let's try another one. Since you're experts at this already, let's try the cube root of negative 27 x to the seventh y to the third z to the tooth. Well, once again, let's write this in such a way where I can get it up from underneath the radical sign. Negative 3 to the third power is negative 27. Okay? X squared to the third power is x to the 6th. I still have an x left, so I'll stick that out here. Okay? Y to the third, z squared. So I just put z squared out here. Okay? So look, I can get rid of the radical sign for this one. I can say -3. I can get rid of the radical sign for this one, say x squared. And because I'm the cube root, this is an odd number, I don't have to worry about any absolute values, okay? Y to the third, that just gives me y. The cube root of y to the third is y. And then I have to have the cube root of whatever's left. I can't take z out because that's z to the second power. So z squared x. And so I'm done. And that's how you simplify these things. And I've got another one for you. Or a reminder, I should say. This is a reminder of something we learned a while back, and that is a to the m over n power equals a to the 1 over n to the m power equals the nth root of a to the m power. And there's another one. A to the m over n also equals a to the m to the 1/nth power, which equals n, or the nth root of a to the m. Now, the easiest way to remember this, the one on top is your power. The one on the bottom is your root. If you remember that, you'll just make it real simple. The one on top is the power, bottom is the root. Okay? Let's try, for example. We got 2 to the 4/5 power. Well, that equals the 5th root of 2 to the 4th. 4 is your power, 5 is your root. Or if you prefer, you can write it the 5th root of 16. Okay? This is the exponential form, not surprisingly. This is the radical form, because you have a radical, of course. And finally, we got, say you got the cube root of 13 to the second power. Now this is also in radical form because I got a radical there. So I want to change it to exponential form. And so I just write it 13. The 2 is on top because that's my power. 3 is on the bottom because that's my root. So these two are equal to each other. And another blue rule, this time I will make it genuine blue. And that is, if A is greater than or equal to 0, B is greater than or equal to 0, and N is a positive integer, then we can say the nth root of A times B equals the nth root of A times the nth root of B. I hope this doesn't throw you away. We've been doing this with square roots for a long time now. So we're just saying that not only does it work with square roots, it works for cube roots or quadruple root, whatever. Okay? And the nth root of A over B equals the nth root of A over the nth root of B. And of course, B cannot equal 0. Because if B equals 0, you know what happens. The Large Hadron Collider in Switzerland will explode, creating a huge black hole in the universe, or in Earth, and it will swallow Earth, and then the solar system, and then the entire universe. So let's try a new example here. Simplify. And this time we're going to assume that each variable has a value greater than or equal to 0. and we will see how many people paid attention to that little thing that I just said. We're going to simplify 27a b to the third to the 1/3 power times the cube root of 5a to the 4th b. Now we have to simplify this stuff. So the first thing I'm going to do is this is to the 1/3 power, this whole thing. So if it's to the 1/3 power, then I can put it under the radical sign. So I got 27a b to the third times cube root of 5a to the 4th b. Now it's time to use those properties we just talked about. And we just combine those two. I got 27a b to the third times 5a to the 4th b. And what does that equal? The cube root. Now I'm going to try to put these in a series of cubes. 27, as we know, is 3 to the 3rd power. Okay? A times a to the 4th equals a to the 5th power. So let's say a to the 3rd power times a to the 2nd power. That makes a to the 5th power. You see what I did is I just took one of these, I say a to the 4th, there's a to the 3rd, and I got one a left. A times a is a to the 2nd power. So then I got b to the 3rd and times b, okay? B to the 3rd and b. So I've got everything all accounted for here. And why did I put it in that goofy form? Because, of course, I've got 3a b times the cube root of b a squared. And I'm done. Oops, I forgot my 5. My bad. 5 goes here and here. 5ba squared. Or 5a squared b if you prefer. But anyway, so what you're doing is you take everything out of there that is the 3rd power and just pull it out from underneath that radical sign. All right, let's try another one. And this time we'll do it in pink. Or, yeah, I think it's pink. All right, let's try another one here. You got 8 times 54x to the 5th to the 1/2 power over 4 times the square root of 3x to the 3rd power. Well, what does that equal? First of all, let's take this whole thing and put it under a radical sign, because I've got 1/2 power. So I can just say 8 times the square root of 54x to the 5th over 4 times the square root of 3x to the 3rd. And what does that equal? Well, 8 over 4 is 2. And then I can use my powers. I can change this to just one radical sign. I can combine those. So I got 54x to the 5th over 3x to the 3rd. And so what I end up with then is 2 times the square root of 54 over 3 is 18. X to the 5th over x to the 3rd is x squared. Okay? And so that makes things real easy. I got 2 times the square root of 9, which is 3 squared, times 2 times x squared. So this and this can come out from underneath that. And so what I end up with is 2 times 3, because the square root of 9 is 3, times x, because the square root of x squared is x. And I don't have to worry about my absolute value, because that little thing I said a little while ago that said assume all values for all variables are positive. Just in these two examples. We'll change that in a minute, but for right now we'll assume the x is positive. And then the square root of 2. Simplifying, 2 times 3 is 6x square root of 2. And so I'm done. And not quite though, because I got some more to do here. And we're going to add and subtract. And we're going to try 6 plus square root of 12 plus negative 7 plus the square root of 75. Now, 12 equals 4 times 3, and 4 is 2 squared. 75 is 25 times 3, and 25 is 5 squared. Why did I say all that? Because that's how we simplify. 6 plus square root of 4 times 3 plus negative 7 plus the square root of 25 times 3. What do I end up with? 6 plus square root of 2 squared times 3 plus negative 7 plus square root of 5 squared times 3 equals 6 plus square root of 2 squared, excuse me, that's not a plus, my bad, times the square root of 3 plus negative 7 plus the square root of 5 squared times the square root of 3. And some of you are way ahead of me now, I'm sure, but 6 plus 2 square root of 3 plus negative 7 plus 5 square root of 3. Because the square root of 5 squared is 5. Square root of 2 squared is 2. And 6 minus 7 is negative 1. 2 plus 5, or 2 times the square root of 3 plus 5 times the square root of 3 is plus 7 times the square root of 3. This is where you have to know your rules of radicals because, well, maybe some of your calculators will do this for you. I don't know. But you need to know how to do this without a calculator, of course. Anyway, try another one. Let's see. Negative 5 minus the square root of 18 minus 6 plus the square root of 50. Already you should be looking at this and saying, yes, that's negative 5 minus square root of 9 times 2 minus 6 plus the square root of 25 times 2. Hopefully that came real easily for you. Negative 5 minus 3 square root of 2. Square root of 9 is 3, so 3 square root of 2. Minus 6 plus 5 square root of 2. So, negative 5 minus 6 is negative 11. Negative 3 square root of 2 minus 5 square root of 2 is a negative 8 square root of 2. And so we're done with that one. Of course, we can go back and double check any of these anytime you want. So don't be freaking out if you don't understand it right off the bat. Let's try another one here. Negative 3. This time we're going to multiply. Negative 3 plus 5 square root of 2 times 4 plus 2 square root of 2. Well, we're going to treat that square root of 2 just like it were an x or an I or whatever, and we're going to FOIL this, okay? Negative 3 times 4 is negative 12. Negative 3 times 2 square root is negative 6 square root of 2. 5 times 4, or 5 square root of 2 times 4 is plus 20 square root of 2. And 5 square root of 2 times 2 square root of 2, well, 2 times 5 is 10, and square root of 2 times the square root of 2 is 2. And so, what do I have? Negative 12 plus 20 is 8. And negative 6 square root of 2 plus 20 square root of 2 is plus 14 square root of 2. And that's how you multiply these things. You've been foiling for a long time now, so hopefully that doesn't blow you away. Let's try another quick example. And this one we've got 4 minus the square root of 3 times 2 square root of 3 plus 5. And 4 times 2 square root of 3 is 8 square root of 3. 4 times 5 is 20. Negative times a positive is a negative 2 times 3, because square root of 3 times square root of 3 is 3. And then negative square root of 3 times a positive 5 is a negative 5 square root of 3. 8 square root of 3 minus 5 square root of 3 is 3 square root of 3. 20 minus 2 times 3 is 6, is 12 minus, plus 3 square root of 3. And yes, I know I'm doing this kind of fast, but I think I made a mistake here. Yeah, 20 minus 6, did I say 6? That's supposed to be 14. My bad. Going too fast. Sorry about that. Very, very quick. Thanks for hanging in there with me, but I'm sorry, I just got one more quick thing. You cannot leave a radical in your denominator. So if you have this, no, can't leave it that way. So how do I change that 1 over square root of 3? I just multiply by the square root of 3 over the square root of 3. So I get square root of 3 over square root of 3 times square root of 3 is 3. And I'm done. Not quite. What happens if I have 2 over 1 plus square root of 3? You guessed it, 1 minus square root of 3 over 1 minus square root of 3 equals 2 minus 2 square root of 3. Okay, you know, I got to distribute that. Over 1 times 1 is 1. Plus square root of 3 minus square root of 3 cancel each other out. That's why we use the conjugate. So square root of 3 times negative square root of minus 3. So that equals minus 2 on the bottom. And please, please, please don't refuse to simplify here. This is actually 2 times 1 minus the square root of 3 over negative 2, which equals negative 1 plus square root of 3. Negative sign, it's a negative 1 minus the square root of 3, so you distribute, you have negative 1 plus the square root of 3, and that's all. Thank you very much. Goodbye.